A seashell's spiral and a planet's orbit share a hidden mathematical language. Our ancestors did not just notice this pattern, they built their world upon it. This journey uncovers 25 ancient blueprint systems, from the pyramids to the temples of India, that masterfully decoded nature's numerical heart. You will discover how these forgotten sciences shaped our history and hold profound insights for our modern understanding of the universe. How did a symbol of 10 dots reveal the structure of creation itself? Why would a civilization build a pyramid as a monument to the number pi? By the end, your perception of the ancient world will be completely transformed. What does it mean that so many different cultures spoke this same geometric language? A single point contains the potential for everything. From that solitary mark emerges a second, then a third, until 10 points form a perfect cascading triangle. This was the Pythagorean Tetractys, a symbol so sacred that members of the ancient order swore oaths never to reveal its secrets. Far more than a simple geometric shape, this arrangement was a complete cosmic blueprint. It mapped a journey from the unmanifest unity of the monad, the single point at the top, all the way to the decad, the completion represented by the 10 points at the base. Each of the 4 rows held a profound meaning corresponding to the very dimensions of reality. The point gave rise to the line expanded into the plane, and the plane blossomed into the solid, 3-dimensional world we inhabit. But the true magic of the Tetractys was not just in its structure, but in the relationships between its numbers. The Pythagoreans were obsessed with harmony, and they discovered that the simple whole number ratios found within this triangle, like 1 to 2, 2 to 3, and 3 to 4, were the exact same ratios that produced the most beautiful and consonant musical intervals. They heard these ratios in the vibrations of a plucked string and believed they could hear them in the movements of the planets, a grand celestial music they called the harmony of the spheres. To them, the Tetractys was the ultimate key, a numerical fingerprint of the universe. It suggested that the same mathematical proportions that create a pleasing chord also govern the growth of a tree and the path of a wandering star. This profound belief in a geometric universe, a reality written in the language of number and ratio, did not end with the Greeks. It echoes across continents, drawing our gaze to the riverbanks of ancient India. Across the sea, while Pythagoras contemplated his perfect triangle, another civilization was building its own testament to cosmic mathematics from the very desert floor. The Great Pyramid of Giza does not simply dominate the landscape, it silently calculates it. This was no crude tomb of a pharaoh, but a monumental machine of stone, engineered with a precision that defies simple explanation. The builders were masters of sacred geometry, weaving fundamental constants of the universe directly into the structure's dimensions. The ratio of the pyramid's perimeter to its height is a close approximation of 2 times pi, the mathematical constant that defines a circle. This means the pyramid's very form encodes the relationship between a circle's circumference and its diameter, a concept supposedly unknown for millennia to come. Even more astonishingly, the pyramid's base perimeter, when scaled up, relates to the circumference of our planet itself. It is as if the entire Earth was the blueprint, and the pyramid is a perfect scale model, a 1 to 43,200 reduction of the northern hemisphere. This was not coincidental artistry, it was deliberate architectural science. For the Egyptians, geometry was a sacred language, a way to bridge the earthly and the divine. By constructing a building that harmonized with the fundamental ratios of nature and the cosmos, they believed they could channel celestial energies and manifest cosmic order on Earth. Their temples and pyramids were not just buildings, they were active blueprints for a harmonious universe, a physical prayer built from mathematics. This intricate fusion of calculation and cosmology reveals a world where number, stone, and star were inseparably linked, a perspective that was emerging independently in the vast, dense jungles of another continent. Deep within the humid jungles of Central America, the Maya looked to the stars and saw a cosmic clockwork. Their civilization was built upon a profound understanding of time, not as a simple linear progression, but as a complex interweaving of celestial rhythms. In dark observatories, priests meticulously tracked the movements of planets, achieving a precision that still astounds astronomers today. They developed a calendar system of breathtaking complexity, a true mathematical blueprint for the cosmos. At its heart were cycles like the 260-day Tzolk'in, a sacred calendar that harmonized with human gestation and agricultural seasons, and the vast long count, which measured epochs in cycles of nearly 400 years. This system required a mathematical concept of profound power, the number zero, a placeholder that gave their calculations immense flexibility and scope. By synchronizing solar years, lunar months, and the 584-day cycle of Venus, the Maya revealed a universe governed by predictable, repeating patterns. They could forecast eclipses and anticipate seasonal shifts with remarkable accuracy, seeing an ordered symphony where others might only hear random noise. For them, time itself was a mathematical structure, a divine architecture woven into the very fabric of nature. This belief that numbers could decode cosmic cycles and even human destiny reveals a mindset that saw calculation as a form of communion with the universe. This same reverence for sacred geometry as a bridge to the divine was being expressed in a different form, carved not into codices but into the very stones of countless temples across India. The precise geometry of the Maya found a parallel in the ritual fires of ancient India. There, the act of building a fire altar was a sacred science, a meticulous ceremony of ropes and stakes governed by texts known as the Sulba Sutras. These were not merely religious manuals, they were the world's first known manuals of geometric algebra. A priest was not just a holy man, he was a master geometer, using a simple chord to lay out perfect squares, rectangles, and circles on the earth. The spiritual goal was absolute precision, for the altar had to possess an exact area to function correctly in the ritual. This seemingly simple requirement forced these ancient scholars into profound mathematical discoveries. To transform one shape into another while preserving its area, they uncovered a fundamental truth of right-angled triangles. They knew that the square on the diagonal of a rectangle is equal to the sum of the squares on its two sides, a principle we now call the Pythagorean theorem, long before the man himself was born. Their pursuit of perfect squares led them to an even more astonishing feat, a remarkably accurate numerical value for the square root of 2. They expressed it as an increase of 1/3 plus 1/3 of a fourth, minus 1/34 of that fourth, a complex fraction that gets incredibly close to the true, irrational number. This was not abstract mathematics for its own sake. Every calculation, every precisely measured line, was part of a grand blueprint to harmonize the human world with the cosmic order, a principle known as Rita. They believed that a perfectly constructed altar would resonate with the universe itself, ensuring the sun would rise, the rains would fall, and cosmic balance would be maintained. This was geometry as a spiritual act, a direct intervention into the very fabric of nature through number and form. That same impulse to align human structures with cosmic patterns was being realized on a massive scale, not with fire and cord, but with towering stones on a windswept plain in England. While the priests of India measured with cords, an earlier civilization was raising stones to the sky with a different kind of precision. On the vast, open expanse of Salisbury Plain, the great Sarsen stones of Stonehenge stand as a silent testament to a forgotten system of measurement. The sheer scale of the monument is humbling, but its true genius lies in a hidden consistency, a standard unit of length that seems to have been used across hundreds of prehistoric sites. This was the megalithic yard, a unit of approximately 2.72 feet. The discovery that this same measurement appears in stone circles from Britain to Brittany suggests something extraordinary, a shared geometric language spoken across Neolithic Europe. It was not a random length, but a carefully derived standard, likely based on astronomical observations or the pendulum swings of a simple stone, turning time into distance. With this common unit, the builders could execute a grand design. The layout of Stonehenge is a complex astronomical calculator, its stones and arches precisely positioned to frame celestial events. The famous heel stone acts as a perfect foresight, marking the point on the horizon where the sun rises on the summer solstice. To achieve such alignments required more than just careful watching. It demanded a practical understanding of geometry that we formally attribute to Pythagoras millennia later. They were using Pythagorean triangles, right-angled triangles with specific whole number ratios, to create perfect perpendiculars and lay out their massive circles with stunning accuracy. This was a blueprint system written in earth and stone, a megalithic mathematics that connected the measure of the land to the cycles of the sun and moon. It demonstrates that long before written history, societies possessed a sophisticated, hands-on knowledge derived from the heavens and the earth itself. This quest for a perfect, repeatable standard of measurement, born from the cosmos, finds a fascinating parallel in a standard born from the human body. Centuries after the last megalithic stone was set in place, a Roman architect named Vitruvian looked not to the heavens for his blueprint, but inward to the human form itself. His revolutionary idea was that the perfect proportions of a well-shaped man could provide the ideal model for sacred architecture. Vitruvian meticulously described how the human body, with arms and legs extended, fits perfectly into both a circle and a square. He detailed the beautiful symmetries within our own anatomy, how the length of a face is 1/10 of the total height, or how the span of the outstretched arms equals a man's height. This was more than an artistic observation, it was a profound philosophical statement. The human body was a microcosm, a miniature reflection of the universal order, and by building temples based on its proportions, humanity could create structures that resonated with the harmony of the cosmos itself. This vision lay dormant for over 1,000 years, waiting for the perfect mind to bring it to life. That mind belonged to Leonardo da Vinci. His iconic Vitruvian Man is not merely a drawing, it is the ultimate expression of this ancient blueprint system. With stunning clarity, Leonardo depicted a man simultaneously inscribed within a circle, representing the divine and eternal, and a square, symbolizing the earthly and material. This single image powerfully argues that humanity is the literal intersection of heaven and earth, and that the mathematics governing our bodies is the same mathematics that should govern our most sacred spaces. The system employed ratios found throughout nature, including approximations of the golden ratio, a proportion seen in everything from seashells to spiral galaxies. A building designed with these human-based proportions was believed to be inherently beautiful and harmonious because it was, in essence, an extension of our own natural order. This human-centric geometry presents a stunning contrast to the systems that came before. Where the pyramid builders looked to the planets and the Maya to the stars, Vitruvius and Leonardo found the entire cosmos reflected in the mirror of the human form. Yet another ancient tradition sought to map a different kind of architecture entirely, the invisible flow of energy that animates all of life. Long after Leonardo's pen sketched the human form, another tradition was mapping an entirely different kind of architecture. In ancient China, the art of Feng Shui provided a blueprint not for stone or brick, but for the invisible currents of life force known as Kai. A master geomancer would take up his luopan, a complex compass ringed with concentric circles of cosmic symbols, and carefully align a home or a tomb with the subtle energies of the earth itself. The heart of this practice was the Bagua, a map of 8 trigrams arranged in a perfect octagon. Each trigram is a stack of 3 lines, either broken to represent yin or solid for yang. These are not arbitrary symbols but mathematical expressions, the 64 possible binary combinations of these 2 fundamental forces. Derived from the ancient I Ching, the Book of Changes, the Bagua represents the 8 fundamental principles of reality, from creative heaven to receptive earth, from fiery clarity to deep, mysterious water. This symbolic map is then superimposed onto the layout of a space, a home, or even an entire landscape. The goal is to diagnose and correct the flow of Kai, ensuring it moves in a harmonious, life-giving pattern rather than a stagnant or chaotic one. A sharp corner pointing at a bed might create cutting energy, while a cluttered hallway could block prosperity. This system is deeply intertwined with the 5 elements and the low Shu square, a 3x3 magic square where every row, column, and diagonal adds up to 15, a number of profound celestial significance. The entire practice is a holistic mathematical model, using directional alignments and symbolic geometry to actively manipulate the energetic patterns of the living world. It posits that our well-being is inextricably linked to our alignment with the mathematical order of the natural world. But what if you wanted to capture the entire order of the cosmos, all its vastness and complexity, and project it onto a flat, 2-dimensional surface? That small clay tablet from Babylon presents a world view we would scarcely recognize today. Encircled by a bitter river, the entire known earth is contained within a single, perfect ring, with the great city of Babylon sitting proudly at its heart. This was not an attempt at literal geography, but a profound mathematical and philosophical statement. The Babylonian cosmos was a place of divine order, a system that could be divided and understood through geometry and number. Their entire worldview was built upon the base 60 numerical system, a legacy that echoes in our 60-minute hours and 360-degree circles. This sophisticated system was not just for counting, it was the essential tool for their astronomers who tracked the paths of planets and for their surveyors who divided the land. It allowed them to create an abstract model of reality, a symbolic blueprint where the mathematical harmony of the design was more important than its topographical accuracy. The map was a testament to their belief that the universe, in all its complexity, could be captured and understood through symmetry and calculation. This desire to reduce the cosmos to a perfect, abstract form would be pushed to its logical extreme by a single Greek philosopher, who dared to suggest that the entire universe was built from 5 perfect shapes. Plato took the idea of a geometric universe to its most elegant and radical conclusion. He declared that the entire chaotic, changing world of our senses is merely a flawed copy of a perfect, eternal realm of pure form. And what were the foundational templates for this perfect reality? 5, and only 5, possible 3-dimensional shapes where every face is an identical regular polygon, and the same number of faces meet at every corner. We know them as the Platonic solids. To Plato, these were not mere mathematical curiosities, they were the literal atoms of creation, he assigned each solid to a classical element, building a geometric blueprint for all matter. The stable, unmoving cube became earth, the sleek and fluid icosahedron was water, the sharp, piercing tetrahedron was fire, the freely floating octahedron was air. And the mysterious fifth solid, the dodecahedron with its 12 pentagonal faces, was reserved for the stuff of the cosmos itself, the constellations in the heavens. This was a breathtaking philosophical leap. It proposed that the deepest secrets of nature were not hidden in the messy details of physics, but in the pristine, untouchable world of abstract mathematics. The flickering flame you see is just an imperfect attempt by our world to manifest the perfect, eternal form of the tetrahedron. The ground you walk on is an approximation of the cube. This system of the 5 solids became a cornerstone of Western esoteric thought for centuries, a powerful symbol that truth was geometric. It represents a profound shift in thinking, where the answer to the question, what is real, was no longer clay or water, but an equation, a ratio, a perfect, invisible shape. This belief that divine artistry was fundamentally mathematical would find one of its most beautiful expressions far to the east, not in philosophy, but in the intricate, repeating patterns of sacred architecture. The geometric purity of Plato's solids finds a breathtaking echo in the swirling stars and complex polygons adorning the walls of the Alhambra Palace. Here, Islamic artists transformed the prohibition against depicting living forms into a profound spiritual language. Their entire system was built upon the circle, the most perfect and universal shape, representing the unity of God. By dividing the circle and connecting its points with straight lines, they generated an entire cosmos of interlocking stars, hexagons, and pentagons. These were not random decorations, but precise, repeating modules that could tile a surface perfectly without gap or overlap in a process called tessellation. This created a powerful visual effect of infinite expansion, a pattern that could theoretically continue forever, mirroring the Islamic philosophical view of a limitless universe emanating from a single divine source. The most advanced of these patterns achieve a level of complexity that modern science has only recently begun to fully appreciate. They exhibit a form of symmetry known as quasi-crystal order, a 5 or 10-fold rotational symmetry that never exactly repeats, yet maintains a perfect, overarching structure. This is the same mathematical principle found in the atomic arrangement of certain metal alloys discovered in the 1980s. Centuries earlier, artisans with compass and straightedge were already encoding this sophisticated non-repeating order into their plaster and tile work. Every line, every intersection was a deliberate act of cosmic cartography, mapping the infinite and transcendent nature of the divine into the physical space of a palace wall. This artistic system was a blueprint for contemplating eternity itself, a visual proof that complexity and beauty arise from the repetition of simple, unified principles. While this art form sought to quantify the divine, another ancient system aimed to measure something equally elusive: the very energy of the human soul. A stark contrast to the Alhambra's infinite patterns, the Kabbalistic tree of life presents a map of descent. 10 luminous spheres, the Sephiroth, are arranged in 3 vertical columns and connected by 22 descending paths. This is not a family tree or an organizational chart, but a dynamic blueprint for the very process of creation. It charts the journey of divine energy from the unknowable, infinite light of the source, down through progressively denser levels of manifestation, until it finally crystallizes into our material world. Each Sephira is a distinct emanation, a facet of the divine with its own name, number, and set of attributes. At the crown is Keter, the primal will, the number 1. At the base is Malkuth, the kingdom, the number 10, which is our physical reality. The entire structure is a profound mathematical and geometric model. The 10 Sephiroth correspond to the 10 points of the Pythagorean Tetractys, a remarkable parallel between distant mystical traditions. The paths between them, 22 in number, correspond to the 22 letters of the Hebrew alphabet, each letter believed to be a channel of creative power. A Kabbalist would use this diagram as a meditative roadmap for spiritual ascent, a process known as climbing the tree. By contemplating the qualities of each sephira and the relationships between them, the seeker aimed to reverse the flow of creation, to ascend from the fragmented consciousness of the material world back toward divine unity. This was a system where numerology and geometry were not abstract sciences, but living tools for inner transformation, describing a universe and a human soul built from the same sacred numbers. If the tree of life mapped the spiritual architecture of the cosmos, where could one find its principles reflected in the audible harmony of the physical world? For centuries, the night sky was understood through a beautiful and intricate lie. Claudius Ptolemy's geocentric model, enshrined in his great work The Almagest, presented a cosmos of stunning mathematical complexity, all revolving around a stationary Earth. The planets did not follow simple paths, but instead traced perplexing loops in the heavens, a phenomenon known as retrograde motion. To save the appearances and preserve the ideal of perfect circular motion, Ptolemy devised a brilliant geometric solution. He proposed that each planet traveled on a small circle called an epicycle, the center of which itself traveled along a larger circle around the Earth, known as the deferent. It was a system of circles moving upon circles, a cosmic clockwork of breathtaking intricacy, with additional tweaks like the equant point, which allowed for variable speeds. This model could predict the positions of planets with remarkable accuracy. It was a monumental achievement, a complete mathematical blueprint that, for over 1,000 years, successfully described the visible universe. The system was fundamentally wrong, of course, but its power lay in its demonstration that the cosmos was orderly and could be understood through geometry and calculation. This persistent human drive to model the heavens mathematically, even from a flawed starting point, created the very framework of data and prediction that would one day allow a new system to arise and shatter the ancient spheres. Johannes Kepler was a man obsessed with cosmic harmony, a mathematician who looked at the night sky and listened for its music. He inherited a universe of perfect circles from Ptolemy and Copernicus, yet the data he inherited from the astronomer Tycho Brahe told a different, messier story. The orbit of Mars simply would not fit a circular path. His faith in a divine geometric plan was so profound that he spent years trying to force the planets into orbits based on the 5 Platonic solids, nesting the spheres within those perfect shapes. But the numbers refused to cooperate. In a monumental leap of intuition, he abandoned 2,000 years of astronomical dogma and proposed a revolutionary idea: the planets move in ellipses with the sun at one focus. This was his first law of planetary motion, a seismic shift in our understanding of the cosmos. But for Kepler, this was only the beginning of the revelation. He pressed further, discovering that a planet sweeps out equal areas in equal times, and most poetically, that the square of a planet's orbital period is proportional to the cube of its average distance from the sun. These were not just descriptive rules, they were fundamental laws of physics, written in the unambiguous language of geometry. Yet his greatest passion was reserved for the work he called Harmonices Mundi, the harmony of the worlds. In it, he calculated the maximum and minimum orbital speeds of the planets as they traveled their elliptical paths. He found that the ratios of these speeds, when compared between different planets, corresponded almost perfectly to the consonant musical intervals of a scale. The ratio of Saturn's slow, deep drone to Jupiter's pitch created a minor third. The relationship between Earth and Mars produced a perfect fifth. The entire solar system, in his mind, was a grand polyphonic choir, singing a harmony inaudible to human ears but perfectly perceptible to the mathematical mind. This was the true fulfillment of the Pythagorean dream, a direct link between the geometry of the heavens and the harmony of music. Kepler had found the sheet music for the cosmos, a blueprint where the same mathematics that guides a planet also structures a symphony. This profound connection between audible vibration and cosmic order finds a stunning echo in a very different tradition, one that used the power of sound itself as a tool for creation. The cosmos sings a silent hymn, and in ancient India, sages listened. They called this foundational principle Nada Brahma, a declaration that the world is sound, a universe born from and sustained by a single primordial vibration. This was not a metaphor, but a precise blueprint system. Just as a specific musical note can shatter a glass, they believed that specific sonic frequencies, encoded in sacred mantras, possessed the power to structure reality itself. Each syllable of a mantra-like Om was not arbitrary, but a precise key, a sonic tool designed to resonate with the underlying geometric matrix of the cosmos. The ultimate visual expression of this cosmic sound is the Sri Yantra, a breathtakingly complex diagram of interlocking triangles. 9 triangles, 4 pointing upward to represent the masculine divine and 5 pointing downward for the feminine, weave together around a central point, the bindu from which all creation emanates. This is not just a beautiful image, it is a frozen symphony, a geometric map of the vibrational structure of the universe. Meditating upon its precise lines and intersections is believed to align one's own consciousness with the fundamental frequencies of creation. The profound implication of Nada Brahma is that the mathematical relationships governing musical harmony and sacred geometry are not merely descriptions of reality, they are its very substance. The same ratios that make a chord pleasing are the invisible architecture of atoms and galaxies. This ancient intuition finds a startling echo in modern string theory, which proposes that the most fundamental level of reality consists not of particles, but of tiny, vibrating strings whose different resonant frequencies give rise to all the forces and matter in the cosmos. The Hindu sages and the theoretical physicists separated by millennia seem to point toward the same stunning possibility, that we live in a universe built from music. And if the universe is a symphony of form, then the ultimate expression of that form would be found in a single, perfect proportion. That same universal vibration seems to favor a very specific mathematical harmony in its physical creations. Uncurl the chambered shell of a nautilus, count the clockwise and counterclockwise spirals in a sunflower's face, and you will find the same number appearing again and again, approximately 1.618. This is the golden ratio, known to the ancients as the divine proportion. It is an irrational number, meaning its decimal places continue forever without repeating, yet it provides a stunningly efficient blueprint for growth and form in the natural world. Its magic is most easily revealed through a simple sequence of numbers, first described in India but famously brought to the West by the mathematician Fibonacci. The sequence begins with 0 and 1, and each subsequent number is the sum of the two before it, giving us 0, 1, 1, 2, 3, 5, 8, 13, and so on, stretching out to infinity. As you move further along this sequence, a remarkable pattern emerges. If you divide any number by the one that precedes it, the result gets closer and closer to that magical number, 1.618. 5 divided by 3 is 1.66, 8 divided by 5 is 1.6, 13 divided by 8 is 1.625, each step a tighter convergence on the golden ratio. This is not a mathematical curiosity. It is a fundamental law of efficient packing and optimal growth. A plant sprouting new leaves or petals wants to maximize its exposure to sun and rain without having new growth block old growth. By arranging each new leaf at a rotation of about 1.618 of a circle from the previous one, it achieves this perfect, non-overlapping spiral pattern. This same mathematical rule governs the branching of trees, the arrangement of pine cones, and the curve of a falcon's dive. It is a pre-programmed algorithm for life itself, a geometric law written into the DNA of countless organisms. The ancient Greeks, who first formalized this ratio, believed it represented a divine aesthetic, a visual harmony so perfect that the human eye is instinctively drawn to it. They embedded it in their most celebrated architecture, from the Parthenon's facade to the proportions of their sacred statues, seeking to infuse their art with the same inherent beauty found in a living, growing thing. This pattern is so fundamental that it even describes the large-scale structure of spiral galaxies, suggesting that the same growth principle operates from the microscopic to the cosmic. The golden ratio shows us that nature is not a haphazard artist, but a master mathematician using a single, elegant equation to build a universe of infinite variety. This quest to capture the very essence of life through geometry would inspire a system that mapped not just physical forms, but the energetic patterns that animate them. From the precise spirals of galaxies to the intricate patterns of quantum fields, a single geometric diagram seems to contain them all, etched into the stone of the Assyrian in Egypt and carved into the temples of ancient China. The flower of life appears as a timeless whisper across civilizations. Its structure is deceptively simple, a series of evenly spaced, overlapping circles that form a perfect hexagonal symmetry, resembling a blossoming flower. Yet this symbol is far more than decoration. It is revered as the primordial blueprint of sacred geometry, the source code from which all other forms emerge. From its central 7 circles, known as the seed of life, unfolds the very template for cellular division and embryonic growth. Expand the pattern further, and you derive the egg of life, the underlying structure of all molecular bonds. Astonishingly, by connecting the centers of these spheres, the 5 perfect Platonic solids themselves materialize from the pattern. This single diagram seems to chart the entire journey of creation, from the first divine impulse to the complex architecture of the physical world. What does it mean that our ancestors, separated by vast oceans, were all drawing the same fundamental map? Modern physicists probing the fabric of space-time have found this same interlocking, hexagonal geometry appearing in their models of the quantum vacuum, the frothing energy sea from which particles blink in and out of existence. The flower of life presents a staggering proposition that the same geometric law governs the shape of a crystal, the structure of a fruit, and the curvature of the universe. If one symbol can encode the blueprints for reality itself, then perhaps the ultimate mastery lies in understanding the geometric laws that govern not just space but time. The seafloor held a secret for 2,000 years, a corroded lump of bronze and wood that would rewrite our understanding of ancient genius. When sponge divers discovered the Antikythera Mechanism in a Roman shipwreck, they had no idea they were retrieving the world's first known analog computer. This was not a simple statue or a piece of jewelry, but a sophisticated machine of at least 30 interlocking bronze gears, housed in a wooden case no larger than a shoebox. By turning a hand crank on the side, an ancient user could set a date and watch as a miniature cosmos sprang into motion. Dials would spin, pointers would advance, and this intricate device would predict the positions of the sun and moon, the phases of our lunar companion, and even the precise timing of solar and lunar eclipses years into the future. Its accuracy was breathtaking, a mechanical mind built to track the complex dance of the heavens. The true brilliance of the mechanism lies in its synthesis of two great mathematical traditions. Its core calculations were based on precise Babylonian astronomical cycles, records of celestial patterns meticulously observed for centuries. But the Greeks translated these numerical cycles into a physical reality using their own mastery of geometry and gear theory. They engineered a complex train of wheels within wheels, with gears possessing teeth in such specific, odd numbers that they could accurately model the varying speeds of the moon's orbit and even correct for its slight wobble. This was a blueprint system made of metal, a tangible, working model of a mathematical cosmos. It took the abstract theories of philosophers and astronomers and gave them turning, clicking, physical form. The Antikythera Mechanism stands as a stunning testament to a level of technological sophistication we never knew existed in the Hellenistic world. It proves that the ancient drive to decode nature's mathematics did not stop at theory or static monuments, but extended into dynamic, precision engineering. It makes you wonder what other mechanical marvels were lost to time, and how a civilization so advanced could have its knowledge simply vanish. This mechanical wonder, with all its moving parts, points toward an even more fundamental question. What if the most profound blueprints of all required no gears, no stone, and no movement whatsoever? Centuries before a machine could be programmed with ones and zeros, the sages of ancient China were already thinking in binary. Their great oracle, the I Ching or Book of Changes, presents a universe built from just two fundamental symbols, a solid line representing the active, creative force of Yang, and a broken line representing the receptive, nurturing force of Yin. These are not static images but dynamic indicators of a world in perpetual flux. By stacking these lines 6 at a time, the system generates 64 possible combinations, known as hexagrams. Each hexagram is a unique 6-line symbol, a snapshot of a specific moment in the cosmic dance between these two primal energies. The hexagram for the creative is 6 solid Yang lines, a moment of pure potential and action. Its opposite, the receptive, is 6 broken Yin lines, a state of total openness and acceptance. Every other hexagram is a complex mixture, a unique recipe of these two ingredients that describes a situation, a relationship, or a phase of change. A consultant would use yarrow stalks or coins to generate a random hexagram, believing that the pattern revealed was not chance, but a meaningful reflection of the underlying order of the universe at that precise instant. This was a predictive and philosophical blueprint for navigating life itself, a guide to understanding how opposing forces give rise to the 10,000 things of our experience. What the ancient Chinese saw as the interplay of yin and yang, a 17th century German philosopher and mathematician named Gottfried Wilhelm Leibniz recognized as pure binary logic. He was developing a system of calculation using only 0 and 1, and when he was shown the I Ching by a Jesuit missionary, he was astounded. He saw the solid Yang lines as ones and the broken Yin lines as zeros, making each of the 64 hexagrams a perfect 6-bit binary number. To Leibniz, this was a breathtaking confirmation that the deepest structure of reality was indeed dualistic and could be perfectly described using a simple 2-state code. The I Ching, therefore, stands as one of humanity's oldest and most profound computational systems. It is a philosophical algorithm, a framework asserting that all complexity, from the growth of a forest to the rise and fall of empires, emerges from the combinatorial possibilities of two basic states. The very same principle of on and off, yes and no, that governs every digital circuit in the smartphone or computer you are using right now was being used millennia ago to map the patterns of a changing world. This ancient quest to measure and understand our world through number and pattern would soon be applied to the grandest scale of all, the very dimensions of the planet we call home. A single well in the Egyptian city of Sin and a simple vertical rod in Alexandria were all Eratosthenes needed to measure the entire world. He had heard a fascinating report that at noon on the summer solstice in Sin, the sun shone directly overhead, illuminating the very bottom of a deep well. This meant the sun was at its zenith, casting no shadow. On the same day and time in Alexandria, several hundred miles to the north, he observed that a vertical rod did cast a shadow. To a lesser mind, this was just a curious fact. To Eratosthenes, it was a global blueprint. He understood that if the earth were flat, there would be no shadow in Alexandria either. The existence of that shadow proved the planet's surface was curved. He carefully measured the angle of the shadow in Alexandria, finding it to be about 7.2 degrees, which is roughly 1/50th of a full circle's 360 degrees. His brilliant deduction was that the physical distance between the two cities must therefore be 1/50th of the Earth's total circumference. He knew the approximate distance between Sin and Alexandria from the paced measurements of professional walkers, and by multiplying that distance by 50, he arrived at a figure for the Earth's circumference that was within a few percent of the value we know today. This was not an abstract theorem confined to papyrus, but a direct physical application of geometry to the planet itself. With a stick and a shadow, he had quantified the world, proving that the mathematics of nature were not locked away in temples but accessible to anyone with a keen eye and a logical mind. This act of turning observation into measurement, of using simple tools to reveal a grand truth, marks a pivotal moment in our relationship with the cosmos. It demonstrated that the universe could be understood through reason and calculation, a principle that would become the bedrock of all modern science. This drive to map the external world with such precision finds a fascinating parallel in a system that sought to turn that focus inward, mapping the intricate universe contained within the human form. The same cosmic order Eratosthenes measured across continents is mirrored within the architecture of your own being. Vedantic philosophy offers a map for this inner universe, a system known as the Panchakosha, or the five sheaths. This is not a physical anatomy, but a layered blueprint of consciousness itself, a journey from the dense outer world to the luminous core of who you truly are. The outermost layer is the Annamaya Kosha, the food sheath, which is your physical body, the earthly vessel composed of the elements you consume. Next lies the Pranamaya Kosha, the energy sheath, a subtle body of vital life force that animates your breath and circulates through invisible channels. Within that resides the Manomaya Kosha, the mental sheath, the realm of your thoughts, emotions, and the constant, chattering stream of your mind. Deeper still is the Vajnanamaya Kosha, the wisdom sheath, the seat of your intuition, discernment, and the direct knowing that transcends mere intellectual thought. And at the very center, like the silent hub of a turning wheel, is the Anandamaya Kosha, the bliss sheath, a state of pure, unconditioned joy and peace that is your fundamental nature. The progression is a mathematical and geometric ascent from gross to subtle, from the many to the one. Each sheath is a kosha, meaning a veil or a covering, and spiritual realization is the process of peeling back these layers to discover the radiant, singular consciousness at the center, the Atman. This fivefold structure is often visualized in sacred art as concentric circles or nested geometric forms, a symbolic representation of the cosmos in miniature. The profound implication is that the same principles of energy, matter, and consciousness that structure a galaxy are operating within you. Your own body is a universe, your breath is its weather, your mind is its cosmos of thoughts, and your deepest self is its silent, central sun. The Vedantic sages taught that by understanding this inner mathematics, by exploring the relationships between these 5 layers, one could achieve liberation. This introspective system presents the ultimate blueprint, suggesting that the final frontier is not a distant star, but the uncharted territory of your own awareness. With this map of the inner world complete, our journey turns outward once more, to the system that read the grandest story of all in the silent, turning patterns of the night sky. A crackle of dry desert air, the scratch of a stylus on a clay tablet, and the slow, majestic drift of a planet against the backdrop of fixed stars. For the Babylonian priests, this was not merely observation, it was translation. They were deciphering a divine text, one written in the silent, precise language of celestial mathematics. Their entire world view was an intricate blueprint system of celestial omens, where the movements of the gods above directly foretold the fate of empires below. A lunar eclipse might warn of a king's impending illness, the appearance of Venus could signal a coming war, and the path of Mars might predict the success of the harvest. Yet this was not superstition divorced from reason. It was a science of correlation, built upon a mountain of meticulously recorded data spanning generations. The true engine of their predictive power was their astonishingly advanced lunar theory. They tracked the moon's daily velocity, noticing it did not move at a constant speed, but accelerated and decelerated in a predictable, repeating cycle. To model this, they invented a brilliant mathematical tool called the zigzag function. Imagine a graph where a line climbs steadily for half its journey, then turns and descends at the same rate, creating a continuous, sawtooth pattern of peaks and valleys. This simple arithmetic progression allowed them to calculate the moon's changing speed and position with stunning accuracy, enabling them to forecast lunar phases and, most impressively, predict eclipses. They had reduced the complex dance of celestial bodies to a reliable numerical rhythm. This system perfectly blurred the line between science and religion, using rigorous observation and pattern recognition to serve a higher purpose, divining the will of the gods. It was a search for cosmic meaning through number, a quest that would soon take a different form, seeking the divine not in the movement of planets, but in the very nature of light itself. Stone reached for the heavens, but it was light that gave these cathedrals their soul. The Gothic architects of medieval Europe did not just build churches, they engineered transcendence, using sacred geometry as their divine blueprint. Their cathedrals were conceived as the celestial Jerusalem made manifest on earth, a perfect city of God rendered in stone and glass. Every aspect of their design was governed by precise mathematical ratios, rooted in the symbolic interplay of the square, representing the earthly realm, and the circle, symbolizing the eternal and divine. By inscribing one within the other, they created a proportional system that they believed mirrored the very harmony of creation. This was a geometry meant to be felt, not just seen. The sweeping vertical lines, the impossible height of the vaulted ceilings, all calculated to pull the gaze and the spirit upward, creating a physical sensation of ascension. The floor plan itself was a vast cross, a cosmic map orienting the faithful within a sacred narrative, but the true genius of this system was its manipulation of light. The great stained glass windows were not mere decorations, they were a metaphysical technology. Sunlight, the physical light of our world, was filtered through colored glass arranged in complex symbolic patterns. Deep blues for the Virgin Mary, radiant reds for the blood of Christ, and gold for the glory of heaven. As this light passed through, it was transformed, becoming a luminous, spiritual substance that filled the interior space. The mathematics extended to the very narratives depicted in the windows. where the number of figures, the arrangement of scenes, and the colors used all followed intricate numerical schemes based on biblical numerology. Worshippers were not standing in a building, they were immersed in a calculated environment designed to elevate the soul, to use geometric perfection as a direct conduit to the divine. This was a blueprint system where number, form, and light fused into a single instrument of revelation. Yet for all its celestial order, the human world often presents a far more chaotic picture, a swirling dance of chance and coincidence that another ancient system sought to master. A river turtle climbing from the murky waters of the Luo carried a divine cipher on its back. Etched into its shell was a simple 3x3 grid of dots, yet this pattern, known as the Shu Square, held a perfect and miraculous balance. Every single row, every column, and even the two main diagonals all added up to the number 15. This was no random design, but the oldest known magic square, and it became a foundational blueprint for ordering the entire universe in ancient Chinese thought. The number 15 was deeply significant, representing the days from a new moon to a full moon, tying the square's harmony directly to the celestial cycles. It was integrated with the 8 trigrams of the I Ching, placed around its perimeter, creating a complete symbolic model of cosmic forces. In the practice of Feng Shui, the Shu's numbers dictated the flow of Kai, with each number corresponding to a specific direction, element, and aspect of life. The central 5 represented earth and stability, while the 8 in the northeast corner was linked to mountains and contemplation. This was a system that believed the very arrangement of numbers in space could influence reality, that a perfectly balanced mathematical array could bring harmony to a home, a city, or a kingdom. The Magic Square was a testament to the idea that cosmic order was at its heart, a matter of numerical equilibrium. This ancient fascination with arranging numbers into perfect, meaningful patterns would find a powerful echo in a system that sought to arrange time itself into a grand, predictive diagram. A serpent devouring its own tail forms a perfect, unbroken circle, a symbol whispering of an eternal truth. The Ouroboros, emerging from the tombs of Egypt and the myths of Greece and the Norse, is far more than a mythological creature. It is a profound blueprint for the very rhythm of reality. This ancient image embodies the principle of cyclical time, the understanding that all things move in great, repeating arcs, where every ending is merely the seed of a new beginning. The sun sets only to rise again, the seasons turn in an endless wheel, and civilizations themselves rise, flourish, and fall, only for their dust to nourish the soil for what comes next. This is not a linear march from past to future, but a cosmic dance of eternal return. Mathematically, the Ouroboros is a stunning model for recursion and feedback loops, processes where the output of a system circles back to become its own input. Think of a forest where fallen leaves decompose to feed the soil, which in turn nourishes the trees that grow new leaves. This is a living feedback loop, a biological Ouroboros. The symbol also represents the mathematical concept of infinity, a loop with no beginning and no end, a process that perpetuates itself forever. Modern science now sees this pattern everywhere, from the complex, self-regulating feedback systems that maintain our planet's climate to the very principles of chaos theory, where simple, repeating rules generate infinite complexity and self-similar patterns known as fractals. A coastline, a fern leaf, a bolt of lightning all exhibit this recursive Ouroboros-like quality, where the pattern of the whole is mirrored in the tiniest parts. This ancient symbol reminds us that nature is not built on straight lines, but on circles, spirals, and loops. It is a timeless blueprint asserting that creation and destruction are 2 points on the same never-ending circle, forever consuming and renewing itself. This final vision of a unified, cyclical cosmos sets the stage for one last grand synthesis, a blueprint that dared to weave all of these threads into a single, magnificent tapestry of everything. The final blueprint is not a single diagram or monument, but the stunning convergence of them all. For thousands of years across every continent, humanity's greatest minds and most devout cultures were all pointing toward the same profound truth. The Sri Yantra's interlocking triangles, the perfect symmetry of the Platonic solids, the efficient growth of the Fibonacci spiral, and the cosmic resonance of the flower of life are not separate systems. They are different dialects of a single, universal language, a foundational code written in geometry and number. This is the unified field of sacred geometry, the ultimate hypothesis that a single set of mathematical principles underpins all of creation, from the quantum realm to the cosmic web. It is the ancient world's grand unified theory, articulated not in equations but in stone, art, and ritual. And in a breathtaking twist, our most advanced modern physics is now whispering the same conclusion. The quest for a unified field theory, a single framework to explain all forces and particles, has led physicists to propose realities with extra, curled-up dimensions. The shapes of these dimensions, known as Calabi-Yau manifolds, are not simple spheres or cubes, but incredibly complex, multi-dimensional geometric forms. The specific vibrational patterns of these tiny, hidden shapes determine the properties of every particle and force in our universe. The universe, according to this cutting-edge view, is quite literally built from geometry. The ancient sages who spoke of Nada Brahma, the world as sound, would instantly recognize the physicist's concept of vibrating strings. The pyramid builders who encoded pi and the Earth's dimensions in stone were mapping the same cosmic constants that define our planet's form today. This is not a coincidence. It is a recurring insight into the nature of reality itself. After this journey through 25 distinct systems, their collective message is undeniable. We have been surrounded by a hidden architecture all along, a silent mathematics that guides the shell's curve, the planet's orbit, and the very structure of our consciousness. These blueprints were humanity's first and most persistent science, a way of seeing the universe as a coherent, intelligent, and beautifully ordered whole. What does this mean for us now? It invites a radical shift in perception, to look upon the natural world not as a collection of random events, but as the elegant expression of a deep and timeless geometric order. We are not separate observers of this mathematics. We are living expressions of it, from the spirals in our inner ears to the rhythmic beat of our hearts. The universe has been speaking in the language of number and form since the beginning. The ancient blueprint systems are our invitation to finally learn how to listen. Scattered across the globe, these 25 systems form a collective whisper from our past. The Pythagorean in Greece contemplating his triangle of 10 points, the Maya priest tracking Venus across the night, the Gothic architect calculating the fall of light through stained glass, all were engaged in the same fundamental quest. They looked at the chaotic diversity of the world and perceived an underlying unity, a consistent language written in the grammar of geometry. A seashell spiral in the Pacific Ocean follows the same logarithmic curve as a galaxy spinning in the deep void, and our ancestors, without ever speaking to one another, each discovered this truth. This is the common language of the ancients, a testament to a universal human intuition that the cosmos is orderly, intelligible, and profoundly mathematical. What we today often separate into distinct categories, science and spirituality, were for them a single, seamless pursuit. The pyramid was both an astronomical observatory and a gateway to the gods. The Sri Yantra was both a meditative diagram and a map of cosmic vibration. Their work suggests that the deepest mysteries of existence are not locked away in one domain or the other, but live precisely in the space where number, form, and consciousness intersect. This unified perspective is not just a historical curiosity, it is a profound challenge to our modern fragmented worldview. It invites us to reconsider the very nature of reality, to see it not as a cold, mechanical accident, but as a coherent, intelligent, and perhaps even conscious expression of geometric law. This ancient synthesis, born from 1,000 different cultures, now points us forward, offering a timeless lens through which to view our own place in the unfolding story of the universe.